4 other hydrogens using its valence electrons. Now, and I also showed you an example where instead of this being a hydrogen here, it could be bonded to another carbon, for example. So now we're going to start naming straight chain compounds that that don't have double bonds or triple bonds in them with more than one carbon. So if I gave you an example such as this, remember that every point counts as a carbon. So we would have a carbon here and a carbon here. All right? And that would have to be using our first 4 prefixes, methane, ethane, propane, and butane, corresponding to 1 carbon, 2 carbons, 3 carbons, and 4 carbons. We would know that since this has 2 carbons, it has to be an ethane molecule. And we draw, once again, we draw the hydrogens as implied. We don't need to put them in, but an ethane molecule would have 6 hydrogens total. And so that's how we start naming compounds with more than 1 carbon. So I'm going to give you another example. And I'm going to try to go in order here. So this one has 1, 2, 3 carbons. This would be named ethane. Or I'm sorry, my mistake. This would be named propane. And why do we use, once again, why do we use the suffix ane? Well, because this has no double bonds or triple bonds. If we were to see something like this as a compound with a double bond in it, you see there's 2 lines right here. This is like a carbon. This right here translates to a carbon with shared valence electrons connecting it to another carbon. That would be what we call an alkene instead of an alkane. And then a triple bond, something like this, would be an alkyne. We're only dealing with alkanes, however, right now. So we know that whenever you don't see a double bond or a triple bond, the suffix when naming a compound is always going to be ane, or A-N-E. So once again, we have 3 carbons on this, so this is going to be a propane molecule. Okay, next up. 1, 2, 3, 4 carbons, so this is going to be a butane. And the next up, we count 1, 2, 3, 4, 5 carbons. Now remember that the methane, ethane, and propane, although still part of the Greek prefix naming system, doesn't include actual Greek prefixes for these names of these compounds. But once we get to 5 carbons and up, we start using Greek prefixes to name them. So we know that the Greek prefix for 5 is penta, like a pentagon. Alright? So this molecule would have to be called, and remember, it's still an alkane, so the suffix is still going to be ane. This molecule would have to be named pentane. Next one. This molecule has 1, 2, 3, 4, 5, 6, 7 carbons. This is a 7-carbon compound with no double bonds or triple bonds. So this, we know the Greek prefix, and you can look up Greek prefixes for 1 through 10 or even higher on the internet, and I drew them for you a little bit earlier in this video series. But the prefix for 7 in the Greek is going to be hept, H-E-P-T. So this has to be named heptane. And this has 1, 2, 3, 4, 5, 6, 7, 8 carbons. It would have to be named octane. So now we're going to start talking about branched carbons. And what do I mean by branched carbons? Well, sometimes you can have a molecule that has a straight chain, something like this, for example, and it can also have carbons branching off of the straight chain of that carbon molecule. So we can have something like this where 2 carbons come off of this 3rd carbon on the straight chain molecule, and then on the next carbon, the 4th carbon, you can have 1, 2, 3, 4 carbons coming off of it. And so we need to understand, how do we name a molecule like this? Well, basically with these type of molecules, you always have to count the longest chain, and the longest chain could not be immediately obvious. For example, counting from left to right on this carbon compound, we can count 1, 2, 3, 4, 5, 6 carbons. That would seem like the longest chain, but what if we counted, instead of going left to right, we counted and then followed this branch coming off of the fourth carbon? We would count 1, 2, 3, 4, 5, 6, 7. Whereas from left to right, we would only count 1, 2, 3, 4, 5, 6 carbons. So this would be the longest chain, and that would be the parent chain of this molecule. And so from that, we derive the Greek suffix that this molecule is going to have, and then we address the branched alkanes. So, for example, if I were to give you something like this compound, for example, you would name it starting with the first carbon. We know that the longest straight chain is going to be going from here to here to here to here, all the way to the seventh carbon. On that, on the third carbon of this parent straight chain, we have 1, 2 carbons coming off of it. And then on the fourth carbon of this parent straight chain, we also have 1, 2 carbons coming off of it. We know that the parent chain is 7 carbons long, so this is still going to be a heptane molecule. But how do we name the branches? Well, the branches have the suffix of YL, or il, instead of ane. That's how we differentiate between the parent chain and the branches of carbons coming off of the parent chain. The parent chain is going to have the suffix ane because it's an alkane, and the branches are going to have the suffix il because they're branches. And that's just the convention in organic chemistry. You just need to know that. Now, what would be the suffix for the branches in this molecule? Well, we still use the same Greek naming system with the first 4, methane, ethane, propane, butane, and the Greek afterwards, except we add the suffix il at the end. So we know that this is a heptane, but we have on the third carbon, we have 2 carbons coming off of that. 2 carbons, the prefix is always going to be eth, so this would be on the second carbon, we would have an ethyl branching off. And these branched carbon chains, we know them as substituents. So the naming system for this substituent coming off of the third carbon, is going to be an ethyl group. Alright? And then on the fourth carbon, we have another ethyl group. And so how will we name this molecule? Well, we denote the ethyl groups by which carbon they are coming off of on the parent chain. So we know that we have an ethyl group on the third carbon, carbon number 3, and an ethyl group on the fourth carbon, carbon number 4. And so this molecule will be named 3, 4, and then we account for how many methyl groups are on this compound, and we do that by saying dimethyl, heptane. And that's how you would name a molecule with branched substituents coming off of it. Once again, 3,4-dimethyl heptane. So now we're going to begin to address how to identify and name cyclic compounds. And what I mean by cyclic compounds is that some of these straight chain compounds can kind of turn in on themselves and attach to the carbons of the straight chain alkane, making a cyclic compound. So let me show you an example. If we were to take just the regular straight chain molecule of propane, 1, 2, 3 carbons, right? 1, 2, 3 carbons. And if that and if one of these carbons, maybe the third carbon, bonded also to the first carbon, we would have, instead of propane, we would have a cyclopropane molecule. That would look something like just a triangle, where the third carbon is bonded to the first carbon. And the way we name these kinds of compounds is the same way we would name a straight chain compound, except we would attach the suffix cyclo to the name of the compound. So this compound, instead of being propane, we have propane here. and this compound would simply be cyclopropane. Now let's use a more complicated example. Get rid of all this stuff here and move this up. Now this has 1, 2, 3, 4, 5, 6 carbons, so this would be a cyclohexane molecule. That would be the name of this compound. But what would happen if we start placing substituents on these cyclic compounds? Well, we would name it pretty much the same way that we would name a substituent on a straight chain compound. So if we were to place 2 carbons coming off of this carbon right here in this molecule, it would simply be called 1-ethyl, and we would name this carbon, since we can place this ethyl technically anywhere on this molecule, wherever we place it, it's still going to be on the first carbon. The convention is to just label that as the first carbon. So we would name this 1-ethyl cyclohexane. Now, dealing with multiple substituents on a cyclic compound, how would we name something like that? Well, let's take this methyl, and I just flipped it around on pause so I know it looks different, but let's take a methyl group and attach it to this carbon right here. And now let's take this is an ethyl group. I keep making that mistake. Ethyl group. There's 2 carbons, so it would be an ethyl. And so let's place 2 methyls here. How would we name this compound? Well, how we tackle this situation is that we would start counting carbons in a clockwise fashion going this way. And what we want to do is we want to give the lowest number at the first point of difference when naming the substituents on this compound. And what I mean by that is if we were to label this carbon right here that the ethyl group is attached to as number 1 carbon, it would take 1, 2, 3, 4 carbons to get to these methyl groups. However, if we were to label this carbon as the first carbon, it would take 1, well, we count this as a first carbon, so 1, 2, 3 to get to this group. So this gives the lowest numbers. From counting from this as the number 1 carbon, it would have taken 4 carbons to get to these methyl groups, but if we start from these methyl groups, it would only take 3. So this compound would be named 1,1-dimethyl cyclohexane with a 3-ethyl in the beginning. So the total name of this molecule would be 3-ethyl 1,1-dimethyl cyclohexane.